Rony's a three-time Doing the Impossible founder. The first company he did was called Mako Surgical. It was a haptical surgical robot, so remote doctors could actually feel gristle in skin and bone through a haptic device. He was told it was impossible. After a multi-billion-dollar exit, the thing is the most successful product at Stryker Surgical 20 years later. His second product was called Magic Leap, which basically was a precursor to what Meta, Facebook, is doing now. It was wildly cool, and he found out that Facebook was going to spend $100 billion to build something, and he only had three. And now he's on his third company, another impossible. And somebody mentioned defense tech, and in defense tech, the big promise of AI is to build new products in a third of the time, and he thinks he can do better than that. For those of you in the AI business, what's interesting here is not just that it's a serial entrepreneur doing stuff, but a whole new approach to training, because his customers are security conscious. They won't allow him to use any commercially available hyperscalers because of data leak and hallucination. And they have their own internal processes for security and need to know. And so Rony, this company is called Synthbee. It's kind of semi in stealth, partly because even I, as a board member, am not allowed to know who the customers are, because they're all, because I don't have a security clearance, which may give you kind of a hint. So Rony, here, you and I are having a Synthbee board meeting here. We've invited a few people to join us. So I hope you can talk a little bit about what customers are looking for. You can say the number one industry is defense tech, complicated machines. The number two industry is med tech, complicated machines. And the next industry is automobiles, complicated machines. We did have one discussion, well, you can go on, but it's amazing that the best humans can take years to get to be good enough to work in one of these companies. And then it takes infinite iterations, which we all know if you've worked on teams. So Rony, how about a little overview of Synthbee, the vision and where you are?
That's great. Can everyone hear me okay?
Yeah, I can see it too. You look awesome.
Oh, thank you. Well, sorry I could not be there in person. Thanks for hosting me remote. Synthbee builds what we call collaborative intelligence. Bing and I have had a lot of discussions about this. We call it CI, and we think of it as a species of computing intelligence adjacent to, but not similar to, AGI, or what most people think of as AI. In fact, we take great pains to distance ourselves a little bit from what most people are currently calling AI, and I'll just explain that in a reason, and it'll define our vision a little bit. Most views of AI is that you're building on top of, or you're a builder of, a very large language model. And I'll explain the issues all of the customers we're talking to in the sectors we're in have with those systems. One of them is, if you're a monolithic system, you're gigantic, you're not transparent, you're almost not testable. In fact, most of the time you're not testable. And lack of testability, lack of transparency, lack of auditability, lack of predictability, lack of control, instabilities, hallucinations, all kind of render a bunch of these systems unusable for a bunch of applications in healthcare, med tech, in aerospace, in certain parts of defense, in automotive, in many industries where you're under all kinds of regulatory scrutiny. You have to engineer things that are mission critical, where people's lives depend on it. And something that you can't understand what's inside it, you don't know how it works, it's hard to predict. All of those things render those systems very incompatible, not just with the regulations, but with the requirements of I want to do something mission critical. It's got to work really well, repeatably well. And think about complex system design engineering is an area that we're tackling, where a lot of current systems were not designed for that. brilliant work went into building large language models, but not to solve these kind of problems. So I thought it was a very interesting area to build a different kind of compute system that we call CI to go tackle that set of sectors, which is adjacent to where most people are launching into with big AI and LLMs.
You have a pretty unique approach to training. You're only the second company I've worked with that has a university president on staff. The first was Coursera, which was university curriculum. You want to share a little bit about Synthby University?
Yeah, we are building something we call Synthby University or Synthby East Island University, which is a bit of an inside joke. But we do have a top 20 university president who is signed on to be the first, guiding advisor, and hopefully you'll become full-time one day, head of Synthby University. And we think about educating Synthbys. And there's a big difference between education and how we think about training data. Education is a matter of continuously building up a set of skills and capabilities and knowledge and reasoning and sort of thinking. So we've decomposed, Big and you and I have talked about this. How do you reverse engineer engineers? So a lot of people may reverse engineer a product. We reverse engineer engineers in order to make really cool things with different people. So our goal wasn't to build the world's largest super brain to do everything. Our goal was, how do we deconstruct the best engineers, designers, scientists on an individual level? And what does that deconstruction look like? And think about that as a system engineer. So almost everyone in the company is an engineer. I'm an engineer. So it's kind of odd to be deconstructing and reverse engineering engineers. But when you start that from a first principle level, you arrive at a architecture, an operating system, and an educational process that isn't the same as filling a giant model with the entire internet and hoping that enlightenment comes from there.
And your customers actually prefer the idea of individual agents or individual systems rather than a single knowledge base to solve everything. They want engineer AIs that have specific knowledge, a specific project history, and to some degree they want to silo the information to keep everybody on a need-to-know basis. But also they know how to manage individuals with track records and LinkedIn profiles. And they've kind of trust that to put a human in charge of a group of AIs, each with named individual personalities like Orville, instead of a single Borg. And talk about that. What's it like talking to your customers about an individual named AI?
Yeah. So first of all, the idea, and I'll just separate out a Synthby from what most people think of as an agent. I won't go into all the details, but we do take some great pains to sort of talk about that. The current prevailing view of an agent is it's something that sits on top of what I call a big blob LLM. Some companies have an agent, you put the thing in your house, you're wearing it on your face, but it is actually not loyal to you. It is loyal to the company. It is sensing and passing on your data. In fact, it's kind of troubling. One of the big AI players just last week, I won't name them here, but announced a change in policy that if you're on the consumer, not enterprise version, effectively all your data and know-how is going to them, which is kind of what to expect from anyone doing that. They have a giant model, and their agent is pretending to be your friend, but actually siphoning your data and know-how and knowledge to the big model. We don't do any such thing. That means Synthbys, which is what we call Synthbys and agents, are second or third cousins, not exactly the same thing. And the reason is there's a key trait we have to have, which is we are not sitting on top of a giant model at all. Self-containment, that everything a Synthby needs is in itself, is very much like when you hire a great engineer to the company, they are not sitting in your organization and passing on stuff to someone else. That would be a violation of confidential and trade secrets. So we want to be not only trusted, but the most trusted entity and organization. That means these architectures that are out there break when you're going to those situations. So we think of a Synthby as self-contained, The reason we picked the single full-time equivalent format for this self-contained format, one, people know how to manage that. They know how to manage something you can wrap your mind around it. And there's a design principle we thought about. And we'll talk about Madden football in a second because it relates to that too. But one of the design principles that people have limited cognitive ability. Our brains are not changing exponentially like computing. There's not a new like NVIDIA GPU pushing our brains better every year. We're kind of how we were for a long time. That means we have to design these systems around our limits to manage them. That doesn't mean the systems themselves have limits. But we want to make sure human managers have a role. People have a role in the future. And that means you chunk down these things so that a human being can manage groups of them and can understand each of the chunks. And we found like a really good container size that we call a SNP for that chunking. And part of that was we wanted to design around human beings' ability to be a very important part of managing and working side by side with like what we call CI in the future, is really in opposition to the idea that AGI replaces all of us. Any company I talk to, any engineers I talk to don't like that. They like the idea that they could level up, that they can manage like superhuman entities that want to work for them, but there's still an important place for you. So one of the key design principles, like reducing some things in the tech to make room for people. I think of this as like very important, like human design factors in what we're doing. The other part is like, you know, if you play a game like Madden football, I'm just going to bring that up because Bing's here. The idea to pick a team, you're the coach, and you give them plays, and they follow your plays. Is something a lot of people that we target grew up playing. They understand that. So when you organize a SNP team, you know how to manage a team, you know how to build a team, and you're kind of their manager and their boss, kind of like you're their coach. So people already have a paradigm in mind on how to do that. The key thing with us is it can't just be on the surface. It has to be 100% true that when they come to work for you, they really come to work for you. There is no signaling back. They're completely and 100% with you and with your team and with your company, and there's no possible way to like, steal, send information, any of that back. We have to architecturally remove that capability, which is interesting because it puts us in the room often when many big companies get shut down. And they get shut down because of the way they're architected to scale on consumer or other business that can't push back. But the people we work with in these mission critical sectors have to push back. They can't tolerate and can't afford any loss of these trade secrets or know-how.
You can even get to the point where you can put the synth bees that a company has hired in a server rack inside one of their buildings with no ability to write to outside systems. So
they could be in a skiff. Yeah, SNP could be in a skiff. It could be completely disconnected. It could still operate just fine. And when you think about becoming a keeper of trade secrets and knowledge and wisdom, one thing a lot of companies are going through, tech companies, but a lot of the companies we target that are like aerospace, defense, government, healthcare, med tech, automotive, complex industrial systems, their graybeards, their best engineers, at some point are going to leave. And the pipeline of the next generation, not that many are coming up, and not that many are willing to apprentice for 20 years or 30 years to gain all those nuances. So there's a very interesting thing that's happening with us where synthbees are becoming keepers of not just like, techs and know-how, but the trade secrets and the knowledge that live in the brain of the best engineers. And those synthbees can be there for hundreds of years now.
So to go to a specific, take airplane design, for example. When you look at a wing of an airplane, you could have a customer that needs to reduce weight, reduce cost, improve stiffness, and improve aerodynamic capability. And they end up having engineers, one person designing struts, one person designing the external material, one person designing the shape, one person even designing the rivets. And my understanding is those engineers go away, and within constraints, they each do a local optimization. and then they get there, there's a group, and some human has to figure out how to reset the optimization. Anybody who's been involved in running a company know you do the same thing with revenue forecasts and with budgeting, and we do it in multiple iterations. Well, you know, you've educated me that with a single thing like an airplane wing, it takes BSMEs a year in the company before they can pass the stress test of a single wing, and the amount of iterations it takes to design a modern wing can be multiple years. And I'll talk
Yeah, Bing,
about.
we'll geek out a little bit because the crowd that you can geek out with a little bit. So think about a complex, let's call it aviation system. Could be space, could be rotor, could be fixed wing, it could be commercial, could be non-commercial. You might have like 10,000 plus parts that are of all sorts of complexity. You might have very sophisticated materials and insanely complex loading conditions, you know, takeoff, landing, all sorts of turbulent flight.
Hey, Rony,
Hey, there's Neil.
Neil just
Oh my
came
God.
in.
Okay, that's cool. Hi, Neil.
That's awesome. In a
Sorry
previous
for the
talk,
tiny geek out.
I was bragging on the Chief Futurist app that he built for Magic Leap that I still want to play.
So anyway, hi Neil. I'll continue, but anyway, nice to see you. So for the crowd, I think what's really interesting is like very, very complex systems. Here's what's happening in today's world, whether it's a complex automobile or aircraft. You have younger engineers coming up trying to use tools that are so sophisticated, they don't know the math and they don't actually understand why these things work. So complex fluid or structural analysis, all kinds of tools that are out there. The things that have flown for decades successfully with high reliability have methods and ways of building them that some of the top companies in the world have been doing and understand why that thing worked and why it didn't. Some of them go back like 100 years. Some of them go back 50 or 60 years. That understanding is actually really key, relating to this test, this thinking led to not just a flight. I think a lot of people think like, I did something and my car runs. I did something and it flew. Doesn't mean tens of thousands of vehicles or hundreds of vehicles will fly successfully for decades. It doesn't mean something will succeed, as a vehicle, let's say an electric car, unless you have thoroughly tested in sort of all sorts of insane ways. That's very, very expensive. So sometimes things could take 10, 15 years to nail. And then other people take shortcuts to say, look, I could get out there in a year or two, but I did a lot of shortcuts on the engineering. What we're trying to solve is how do you actually do the right work that could take 10, 15 years, but maybe do that in months, maybe do that in weeks. So this idea of hyper accelerating the complex engineering and design work innovation cycles, not shortcutting, but doing them insanely fast at levels of depth and levels of accuracy that's almost superhuman.
And then if you compare two synthbees, one Orville who worked successfully on a completed aviation system or a wing, and somebody else who's just graduated, how are they instantiated differently? So you've got kind of local experiential knowledge for one of them, and how do you put that into memory, an operating memory for that synthbee?
Yeah, it's kind of weird where people think, why are they not all the same? First of all, there's a lot of goodness in variance, especially in engineering, having different points of views and different skills. But imagine you graduate, let's say MIT, PhD in aeronautics and aerodynamics. You end up working for an electric car company or a rotor company. Your experience building, let's say, propellers or a turbine engine system will be different than a different student's experience building structure for the body or landing gears. And what you want is that depth and focus and interaction with a team that becomes better and better over time. Actually, was very inspired from the film Hero Loves Sushi, which is like, 10 years just to become the guy that cooks rice. If you want to become the world's best at something, and I think what companies want are the world's best that's extremely good at something. If you're generally good at a bunch of stuff to an 80% level, you're basically useless to any customer we work with. They want the 99.99% amazing in all the things they do. Because if you fly in a plane, have a medical device in your body, ride down the highway at 85 miles an hour, you want to make sure the engineering was done by the best of the best. Nobody wants the, oh, I'm flying overseas right now. The 80 percentile AGI built the engine. It's going to be okay. Nobody wants that. You want like the world's best, most obsessed team of people whose entire life was making sure that engine runs well, never has fatigue issues, never falls apart. That's what you want in there when it's you in the air, when it's your parents, when it's your mom with that implant. So, whether it's medical device, automotive, mission critical, you want that insane obsession and specialization that comes by being highly focused and by constantly learning in that highly focused area. So I think that's where this differentiation comes from. You might get your PhD and your fellowship as a doctoral student, but still hyper specialize one day when you come into an organization to become the world's best at something.
So you have customers who are saying if we continue to outperform in their tests, that they want to hire thousands of the synthbees. So 5 years from now, how does synthbee help on job creation?
That's a great question. I've actually had conversations with students and talks and university professors. Here's my blunt, candid perspective for this audience. If you are an average or below average technical player who has no system thinking and is not accumulating the fundamental physics and engineering and design skills, you're probably not going to have a real role in the future. However, if you work incredibly hard on a couple things, like you know the fundamentals, don't sit there with like some AI tool and think that it's going to replace you and that you will be okay. You need to teach yourself the basic fundamental math, physics, engineering, know the equations, know what's going on, so that you could be both a manager of very intelligent entities under you. You have to be able to check their work, understand their rationalization, know their thinking, know why they did their job. That means you cannot rely on a half-baked AI to do that. You need to know the stuff yourself. You need to become a great engineer. That's like hard work, fundamentals, know what's going on in physics and engineering. So I'm encouraging every student, don't give up on that. Do not hand that off to AI systems. Learn that yourself. Two, you got to be a system thinker. A system thinker means you're not just in this little tiny hole. You can manage 5, 10, 15 superhuman entities to like not just do a part, but you're going to learn how to take an assembly, a whole wing, an entire aircraft, because now you become a 10Xer that's supported by 1,000Xers, and you're incredibly valuable in the future to any company.
You're also imagining that before long, a single synthbee agent can be your favorite professor. And so that students will have access, basically office hours, to a synthbee as a learning coach.
Yeah, something I've noticed, Bing, and you and I've talked about this, is that at every company we're talking to, and companies I've actually worked with over the years, the principal staff engineers that know everything, they eke it out very slowly to the younger generation coming in. When you're a young engineer coming out of school, you're getting hazed. It's hard to figure out what's going on. And that 25-year veteran might give you a couple hours a week if you're lucky, maybe an hour a month. And it's like sink or swim. A Simpy, on the other hand, that knows everything, has no ego. It could literally spend its time teaching a new kid out of school how to become the boss of that superlative Simpy. So I think this egoless collaboration is really key to the future of people as well. Not you imparting your knowledge to them so they suck you dry, but the idea of a Simpy is that it will help you become better. It will impart its knowledge and skills and wisdom to you so that you are actually able to ascend and become its boss. I think that model of computing intelligence is really important.
Do you want to talk about how you use the concept of chain of thought as a way to create auditability for each of the synthbee engineers?
I'll be really careful with that because some of this stuff is still interesting IP and development. But we do right now, and I think it's important for anyone in this kind of field, when when a Simpy does work, it mirrors the very best students and the very best engineers. So what do the very best engineers do? They will not just show you an answer. They will explain in detail how they got there. You can read their papers. You could read their notebooks. You could read their essays. This is how I got there. This is how I thought through it. If you're at Stanford, you get an A plus when you show how you think and the answer is right. Just the right answer is not going to do it for you. So the how you think through the problem, how you reason in great detail, to the exquisite detail that you want at the highest level, almost like a master's thesis or PhD thesis level. That's what synths are doing, but that auditability and that level of detail is actually what the best engineers also do. It allows us to no longer be dependent on what did that thing do, but here it is. We can go recreate it in the future. It's human readable, it's understandable, it's also verifiably true, which is very important in a world of hallucination. Verifiably true. You can independently take that work and go run all the math yourself and come up with the same answer. Test it a different way. So in a world where everything's hallucinating, you want to know things that are verifiably true and testable and provable. It's a different way you have to work in this field.
There's a question from the audience about training of ethics, and this probably can even go back to your own personal journey, because I know that you are a humanist, and that was one of the drivers of Mako. But when you talk to the university president, and there are classes on ethics in engineering, how do you build in kind of a single ethics curriculum? How do you give customers their own bounds on ethics for the engineers they want to hire? Basically,
Yeah.
how do you get EQ and humanity trained in?
Let me being explained for a second. It's a really good question. What inspires me on what we're doing, and I'll explain what we did at Mako, how I'm reusing some of that at Simpy and where we're going past it. At Mako, we had a couple things. One, we built Asimov's laws, the theory behind them, into the robot. So it's not just something you read about, but like, how do you actually make something safe? And Mako's done like now more than 2 million cases, like a nearly perfect clinical track record. Part of that success is we put in a watchdog safety circuit that looked at the behavior of the robot. Anything that was going to cause harm or do something off would put the system in a safe position. And it was running at a cycle rate of like thousands of times per second, I think close to 4,000 times per second, looking at behavior and all these different things that can go wrong in order to build trust. The other ethic was a little more EQ and humanistic, like you're saying, is the idea that we were not trying to take over the operating room. We were competing at Mako with people that said an AGI robot will replace everybody. We beat those companies. In fact, the idea of collaborative intelligence comes from that idea of collaborative robotics that we helped pioneer. And the idea was a teammate robot, literally inspired by R2-D2. Everyone I talked to about this, I go, R2 was our inspiration. The Mako was blue and white, looking like R2 because of that. The idea that you could have a friend that was a teammate and really was egoless and trying to help the team turned out to be true. There's thousands of Mako sites. If you go query them, there's a bunch in California too. You'll ask the teams and they'll see this thing became a teammate and a non-threatening member of the team. I looked at that as a way forward for people and computing intelligence to have this new relationship. The next level of ethics is really interesting, right? This idea of bounding and governing. So follow regulations. If I'm in aerospace and aviation, I should follow the FDA regs. If I'm in FDA, I will follow FDA regulations. And what are the other ethics that if you're a biomedical engineer in the field, which I am, you sign on a biomedical engineering code of ethics. So what are the ethical codes of engineering levels and things that you want to do? And how do you get these non-human entities that are becoming more and more capable to follow those same ethics and that same governance and rules? And also the code and policy of my company. You know, if you were simply working in a company, you should be able to also fit in and follow that company's code. For example, Johnson Johnson has a almost 100-year-old set of code of ethics. So if you worked at that company as a person or a synthpy, you would want that synthpy to follow to the T that really good code of ethics that they want their humans to follow. Why should this intelligence have some exception and also be bound to someone else? The problem with AGI systems, they have a different master. It's a handful of people somewhere else, not inside your company, who could turn dials and change the behavior. And that's not exactly what you want when you have an employee working for you, supposed to be, loyal to your company, to your ethics, to your systems.
I think we are out of time, so I'm going to cut us off, and I'll talk to you soon. Thanks a million, Rony Abowitz.
Thank you, everyone.